Hi, today we are going to discuss about LTE, long-term evolution, that is our fourth generation networks. So what do you mean by long-term evolution? So in order to achieve a high mobile data rate communication of 100 Mbps per second and high fixed rate communication of 1 gigabits per second, we have evolved for long-term evolution. So let us discuss our LTE in detail. LTE is designed to support package switch services. So in the previous third generation, so we have in the core net the circuit switch services as well as the packet switch services. So in the third generation, it support both the services. So what your circuit switch services is going to provide is the voice calls. So in the packet switch services, it is going to provide internet services and multimedia services. As in the starting stage of the fourth generation, it doesn't support voice call. So it is going to switch whenever a voice call has been initiated. It is going to switch back to the second generation or third generation network for voice calls. After the invent of voice over LTE with the help of the IP multimedia subsystem, voice over LTE is possible. That is without switching back to the second and third generation network. So in order if we switch back to the second or third generation, the data speed also will be cut. So after the advent of voice over LTE with the help of IMS, we can make a high definition calling, better user experience, and faster calling is possible with this system. So and also LTE provides a connectivity between the user equipment and the packet data network with the help of the IP Internet Protocol. So what is a packet data network? It is a general term of IP services, and so the packet data network is going to provide services for the user equipment. That is, it contains IP services as well as the IMS. So, what a LTE is? So, LTE in the third generation, we have the UMTS, that is UMTS Radio Access Network. So, from the third generation to the fourth generation, we have the evolved Utron. So, similarly, we have a core network of that is a UMTS core network in the third generation. So, here it is for the non-radio aspects, that is, it is called a system architecture evolution that includes the evolved packet core in the fourth generation. So combining these LTE and the SAE forms the evolved packet system. The evolved packet system uses the concept of evolved packet system barriers. Barriers are nothing but a signaling messages that has been transferred between the user equipment to the PDN or the PDN to the UE. So here the EPS barrier is used to route the IP traffic between the user equipment and to the PDN network or PDN to the user equipment. So here barrier is an IP packet flow with a defined QoS between the gateway and the user equipment. So this diagram depicts the LTE, that is the LTE is the connectivity between the user equipment to the packet data network server. So in between is the eUtron and the EPC, that is the evolved Utron in the fourth generation and the evolved packet core that is evolved from the 3G to the 4G. Evolved packet system network elements. So the evolved packet system is nothing but the eUtron and the evolved packet core. So eUtron is evolved UMTS terrestrial radio access network. So first is the user equipment and next is the eUtron part. In the eUtron part, we have the E node B. So node B in UMTS we have, in the Utron part we'll be having RNC and the node B. So here in the fourth generation we are going to have the evolved node B. The node B is nothing but the base station that is being used in the 2G. So here in the fourth generation we called it as the evolved node B. Next, in the evolved packet core, we have five things, that is the mobility management entity, home subscriber server, serving gateway, PDN gateway, and policy control and charging rules function. So this all forms the EPS network elements. So the last is the PDN network server. So that is we are going to have in the PDN network server is the internet services and the IMS. Let us discuss about the functions of the eUtron and the EPC. The eUtron is the air interface of the long-term evolution. So it is entirely a new air interface system that it replaces the third generation UMTS high-speed downlink packet access and high-speed uplink packet access. It provides the higher data rates and lower latency. So the EUtron uses orthogonal frequency division multiplexing access for the downlink and single carrier frequency division multiplexing access for the uplink. So the EUtron is a single node. The node consists of a single node, that is the E node B. So the E node B is the interface to the user equipment, and the other E node Bs will be interface with the help of X2 interface, and the E node B will be interfacing to the core network, that is the mobility management entity or the serving gateway. So with the help of the S1 interface only, it is going to interface with the packet switch, that is the EPC. Evolved Packet Core Network. So the functions of the E node B. The functions are inter-cell radio resource management. It manages the radio resources available to the base station. So next is radio bearer control, mobility control, radio admission control, node B, E node B measurement configuration, dynamic resource allocation. So the layers present in the EUtron are physical layer, MAC layer, RLC, packet data convergence protocol, and radio resource control. So in the evolved packet core, we have the mobility management entity. So in the mobility management entity, we have the non-access stratum. So what is the purpose of non-access stratum is, it is used to manage the establishment of communication sessions and for maintaining the continuous communications with the user equipment. So whenever the user moves, it is going to maintain the communication between these user equipments. So next is mobility handling and the EPS bearer control. So it is going to control the bearers as well as the session control. So what is the serving gateway? So serving gateway serves the local mobility anchor for the data bearers when the user equipment moves between the E node B. So it is going to serve the mobility as well as going to serve it to the next PDN gateway. So what is the work of PDN gateway? So it allocates the IP addresses and it filters the packets, IP packets that has been transferred from through the PDN gateway. So these are the functions. And architecture reference model contains two distinct components, that is, one is the access network and other one is the core network. In the access network, it has the EUtron part, and in the core network, it has the EPC part. In the EPC, we have the home subscriber server. The home subscriber server contains the whole user's profile, and it can able to track the activities of the user. That is, it contains a AAA function, authorization, authentication, and accounting. So the next is the PCRF. PCRF is policy control and charging rule function. So it contains two things. One is the subscriber profile repository and other is the policy and charging enforcement function. The subscriber profile repository contains the latest data and voice plans that the subscriber has been subscribed to. So whenever if we have a voice data of 1 GB per day, whenever it exceeds the limit of 1 GB, a message will be displaying that you have exceeded the limit and the plans will be cancelled. So the PCRF is responsible for providing a control for your validity and data plans. And similarly for making calls, the charging will be done according to the charging rules function. So the whole policy control and charging rule function makes the decision making for the subscriber profile that the user has been subscribed to. So the PDN gateway is connected to the PDN network, PDN server that provides the IMS or IP services that the user equipment is subscribed for. In the protocol architecture, the protocol stack has two planes. One is the user plane and the control plane. The user plane handles the data generated by the user and the control plane handles the signaling messages in the network. The diagram depicts the user plane end-to-end protocol stack. So in the user plane, the radio access uses the MAC, RLC and PDCP protocols. So medium access control, RLC radio link control, and PDCP packet data convergence protocol. So in the user plane part, the S1 interface, so the S1 interface is nothing but the interface between the Utron and the evolved packet core. So the S1 interface connects the node B with your mobility management entity or the serving gateway. So the S1 part in the user plane is based on the GPRS tunneling protocol GTP. So this tunneling mechanism is used to ensure the IP package that is being destined to the particular user equipment is delivered to the E-node B that the user equipment is connected to. So how it is going to ensure is, it is going to encapsulate the IP packet header to the outer IP packet so that the new header is destined addressed to the E-node B that the user equipment is connected to. So with the help of this, the GTP ensures the IP packet is being delivered to the particular E-node B that the user equipment is being connected to. So next we will see about the control plane. So the control plane is used to control the signaling messages between the EUtron and the EPC. So what are the control functions the control plane is going to provide is, it can control the EUtron network access connections, that is it can attach or detach from a EUtron. It can establish the network access connections by activating an IP, and it can control the routing path of the established network connections by supporting or providing mobility to the user, and it can able to assign the network resources as per the required user. So whatever the user demands, it is going to provide the required resources for that particular user. So in the control plane, we have non-access stratum in the user equipment and the mobility management entity. So the topmost is the non-access stratum. So what is the non-access stratum? Stratum is to manage the call as well as in order to establish and to have a continuous communication between the call. So these things will be managed by your NAS. So it is going to provide network attachment, authentication, it sets up the barrier and provides mobility management. So all the NAS messages is being ciphered and it is protected by the MME and the UE. So what is the use of radio resource control is, it is going to help with the handovers. So depending upon the cell measurements, it is going to predict which E node B is nearby, so in order to hand over to the next E node B. So that is the radio resource control. So it is going to hand over as well as it is responsible for setting up and maintenance of the radio barriers. So whenever a call is being established, it is going to send signaling to the for setting up and maintenance of radio barriers. So with this LTE, we came to the end of the LTE. So next we will see the advantages of the LTE. So the advantages of the LTE are high throughput, low latency. It supports both frequency division duplexing and time division duplexing in the same platform. It has superior end user experience, reduced latency to 10 milliseconds for better user experience, seamless connection, plug and play as it doesn't require any hardware or things to get installed. So it has everything inside it, so we can directly plug and play. So it is a simple architecture that has low OPEX, that is operating expenditure is very low. Thank you.